All right, so I'm going to go over the spring break assignment, the differential equation packet. Sorry, wait. Hey everyone, this is Mr. Canfield. There, okay. So one of the biggest things that I want to emphasize is there's a whole book on differential equations. And there's a whole course on differential equations. There's a lot to, oh, that's cool, a swaying skyscraper. Hey, look at the cool graphs. Anyway, we are going to, I don't even want to say we're going to scratch the surface. We're going to like lightly brush the surface of differential equations in this course. So, all right, what is a differential equation? Simply put, it's an equation with a derivative in it. I know that was probably really hard, but that's a differential equation. So is that, and so is that. So the way that this notes packet is devised is there's going to be an example, and it's going to show the steps over here, and it's going to explain the steps over here. I think what might be beneficial is I'm going to write down the actual question, and I'm just going to do the question. So if you're going to do this along with me, you almost want to cover up your notes here and just kind of do the problems out. And that's what's going to happen. So I'm actually going to go through, probably going to be a couple videos, probably a couple hours, but if you go through this, I am going to go through every single example in this packet, including every single homework problem. So that's my plan with this. So let's go. It even starts out and it says, how do you solve a differential equation? Solve might sound kind of weird considering it says this junk is equal to that other junk. Oh man, am I really out of focus? Wait. Hold the phone. Oh, unintentional pun. Oh, that's why. My clear whiteboard that I balance my phone on. Not clear whiteboard, my clear, yeah, here's my streaming setup. It's resting on this guy. So professional. All right. Whoa, come on. There we go. So these are all differential equations. Cool. So the way that we're going to solve them is we're actually going to take dy dx and we're going to split it up. And we're going to separate our variables. We're going to have y's over on the left side, x's over on the right side in general. We're going to integrate both sides and then get y by itself. That's kind of that's what it says here. So our first example, it says solve dy dx is equal to 2x at f of 1 is equal to 6. All right, so first thing we're going to do is we're going to make sure that this is on the screen. Okay, so is it just me or is it not focusing as well as it normally does? Hold on, I'm going to pause real quick. Hey, I'm back. I cleaned off the lens. I think that was the issue. So big idea here is if I multiply both sides by dx, I can say dy is equal to 2x dx. And now we have a situation where we could integrate both sides. And the right-hand side is actually going to be the easier of the two for us to think about most likely, because this looks just like every integral we've done this year. Well, the integral of 2x is just x squared. And the 2 is going to wind up not even needing to be anywhere else. And then we'll have our plus c. And that's our antiderivative. Over on the left-hand side, we might be a little bit confused because there's nothing in there. But remember, if there's nothing in there, it means there's a 1 there. So the antiderivative of 1 dy would just be y. Now, something that we don't generally write is we don't generally write the plus c over here. And we talked about this, I think, early on when we were talking about integrals. And the idea is we could call this like c1 and this c2. Like they're two different constants of integration. And what I could do is I could subtract this constant of integration from both sides. I can get y is equal to x squared plus c1 minus c2. And I could rewrite that as y equals x squared plus c3. Like But all of that is really unnecessary if we understand that these different c values can kind of be mushed together, since they're all arbitrary anyway. So it says solve the dy dx is equal to 2x at f of 1 is equal to 6. So when we plug in 1 to our original function, we get 6, and that's how we find c. So we're going to say, well, when I plug in 1, that's 1 squared. We get out 6, and there's the plus c. And I'm just going to drop the subscript because it's an arbitrary constant. So 6 is equal to 1 plus c, so we'll subtract the 1 from both sides, and we'll get that c is equal to 5. And so my solution to a differential equation is going to actually be an equation. It's going to be y is equal to x squared plus 5. So now what I'm going to do is I'm going to go back and look at the original, and I'm just going to see and make sure that I kind of followed the steps I was supposed to, and cool, looks good. So you can check by taking the derivative implicitly of the final answer and see if you get the original problem. Yeah, if I took this derivative now, I'd get dy dx is equal to 2x. Wow, I'm so surprised. So that's that. All right, I've turned the page magically. And what this problem has is it says dy dx is equal to 2x squared over 3y cubed. And then we want to find the solution at f of negative 3 is equal to 2. And so this is where we start running into needing to separate our variables. So it says 2x squared over 3y cubed. Well, I can just multiply both sides, right? And I can say 3y cubed dy is equal to 2x squared dx. And we have that situation. Well, now if I were to integrate both sides, on our left we get 3y to the fourth over 4 is equal to 2x to the third over 3. And I'm going to put my plus c over here. And so now if I was going to solve and get y by itself, I'd multiply both sides by 4 and divide by 3, or just multiply by 4/3. And so I could say 3y to, wait, that's not that anymore. Y to the fourth is equal to 8/9 x cubed. Now I could say plus 4/3 c, but c is going to be a constant. It's going to be a number anyway, so I'm just going to leave it as c. I don't need to like solve and get like the smallest version of c, because it's just going to be a number in the end. So in case you missed that, 4/3 c is equal to a number, and that's also just a number. So that's why I'm just going to write it plus c. So now when I take the fourth root of both sides, I get y is equal to the fourth root of 8/9 x cubed plus c. Now the fourth root is even, so I would technically need plus or minus. I want to see what I did in the notes here. All right, yeah, okay. So in my notes, I didn't actually get here yet. I found c earlier, so I'm going to stick with what I started with and then see what happens. So when we plug in negative 3, we get out 2. That's going to be 2 is equal to plus or minus the fourth root of, let's see, 8/9 times x cubed. 8/9 times negative 3 cubed plus c. Yeah, this might have been a bad idea. This is going to be really annoying to solve for c. So I'll go back here and I'll say y to the fourth is equal to 8/9 x cubed plus c. So now when I plug in negative 3, I get 8/9 times negative 3 cubed is equal to 2 to the fourth. And the plus c is still over here. So I get 16 is equal to, let's see, that's going to be 27, and then divided by 9 is going to be 3. So, but it's negative 27 because it's cubed. So that's 8 times negative 3 plus c. So 16 is equal to negative 24 plus c. Add the 24 to both sides. And we get that c is equal to 40. And so that was going to be the c value in here. So now I could say c is 40 and get y is equal to plus or minus the 4th root of 8/9 x cubed plus 40. And we're going to use our initial condition to inform this situation right now. We took the 4th root, which gives us the plus or minus, but it says when we plug in -3, we get out a positive number. And so out of these two, we would wind up needing the positive one. And so we're just going to focus on the positive out of the two possible 4th roots. So if we look over here, ew. Oh, okay. Cool, I did it wrong. Hooray. What did I did wrong? No. Oh, okay. So, just for clarity's sake, my C is different than the note's C. Okay, cool. Really good opportunity for us to talk about things. So, if we look down here, their ending and my ending is actually the same. You know, if we put this over 9 times 40 is 360. So these are the same thing, but I got 40 for C and they got 30 for C. And the reason is they didn't solve for y here. Like I got y to the 4th by itself. They didn't. When I got y to the 4th by itself, my C actually changed. Remember how here I was like 4/3 C is the same, like whatever. So when they found this C that was 30, and I just found that, which was like, I don't really care. It's going to be 40 when I multiply by 4/3. So you might sometimes get a different C value. It's more about, do we end up at the same place? So I meant to do that. That wasn't an accident. It was totally an accident. All right. The next problem. All right, and I think this is going to have to be the last one I do in this sitting. So this will be the end of part 1. dy dx is equal to x squared y at 0, 3. Ooh, fancy! Oh man, I don't know what it's going to... Oh wait, that's x, that's y, the end. Okay, so now when we do separation of variables and I multiply both sides by dx, I get x squared y dx. I gotta get the y over here. The only way to do that is to divide. So I'd say dy over y is equal to x squared dx. Now, last time I checked, that's kind of weird looking. How about I write it as 1 over y dy is equal to x squared dx. That might be a more helpful thing, because when we throw the integral on it, this is an integral you should know. Remember, it's just 1 over x. It's just a different letter. So if you do not know what that integral is, you need to go look it up right now. Like, pause the video, walk away, find it, because you absolutely need to know this on the AP test. It's going to show up a lot. You done? Did you get it? What is it? Tell me. No, tell me. Say it out loud. Just say it out loud. The integral of 1 over x, or the integral of 1 over y, is, right, the natural log of the absolute value of whatever that is. Plus c, whatever. So here we get our x cubed over 3 plus c. I'm kind of disappointed that you didn't say it out loud. Oh wait, no, well, no, you did, but they didn't. All right, dumb joking aside. Okay, so we can find out what c is really quick, or we can find it out later. It doesn't really matter. So if I were to find it now, I'd plug in, let's see, I get ln 3, and I can drop the absolute value bars, because what's the absolute value of 3? You know what? Let's just leave it there for a second. Okay, absolute value of 3. And then I plug in 0 for x plus c. Absolute value of 3 is 3. So ln 3 is equal to c. I'm going to show you an alternate way to do this that is going to look a little bit better in the end, or feel probably a little bit easier in the end. So we got our c value. We can say ln y is equal to x cubed over 3 plus ln 3. And I want to get y by itself, so what I'm going to do is I'm going to e it. I'm going to e both sides. And so if you don't remember this property, but e to the ln cancels out, and all we're left with is this, this absolute value of y. And over here, we've got e to the x cubed over 3 plus ln 3. That's our exponent, which is like, you know, a moderate amount of vomit, I think. Now, question, e to the something, when is that negative? And if you don't remember, e to the x looks like this, swoop. And it's actually never negative. Since it's never negative, I can actually say this is y is equal to e to the x cubed over 3 plus ln 3. You're never going to see it like that, though. The plus ln 3, we're going to simplify this. You're really going to hate this way when I show you the other way. So y is equal to, remember, plus means we can say it's e to the x cubed over 3 times e to the ln 3. And remember what we said earlier, e to the ln, they just cancel each other out, and it's just going to be a 3. So I can write this as y is equal to 3 e to the x cubed over 3. And there is my solution to the differential equation at 0, 3. There it is. So again, this is the undesirable way. The better way to do a problem like this is before we find c here, solving this for y early is actually good. Because if we e both sides here, e to the ln of y is equal to e to the x cubed over 3 plus c. There's a little shortcut that we can do on something like this. So remember a minute ago, we said e to the x cubed over 3 plus ln 3. We were able to break that up, and then that wound up just, so I'm going to do the same thing here. So on the left-hand side, we're going to have a y. Remember, the absolute value bars fall off because it's e to something. Over here, we get e to the x cubed over 3 times e to the c. But wait a minute, e to the c, that's e to a number, it's to some arbitrary constant. I could just call this an arbitrary constant. And so we're going to say y is equal to capital C e to the x cubed over 3. Again, this is a different c than that one. So if it would make you feel better, you put the little ones there and put a 2 here or something. I'm just using a capital C to differentiate it. And then now if I plug in my stuff, I plug in 0 for x, we get e to the 0, which is 0, y value of 3. We get y is equal to 3 e to the x cubed over 3. It's faster and it's nicer. And almost nobody does it this way. Almost everyone does it this way. So where are we going from here? The next video, that's where we're going. In the next video, we're going to deal with starting to see unfriendly scenarios. So, TTFN.